Now let us discuss the equation of state for an adiabatic process. We have used many times PV to the power gamma is equal to constant, but let us derive now this. So in an adiabatic process, the heat exchange between the system and the surroundings is not allowed. So from first law means first law of thermodynamics, we have delta Q is equal to delta U plus delta W. For an adiabatic process, this is 0 and this is N CV dt. This is for any process and this is P dV. So we have this equation number 1. So this is valid for an adiabatic process for which there is no heat exchange taking place, delta Q. Heat exchange is not allowed. No heat enters and goes out of the system. So this is 0. Now from ideal gas law, we have PV is equal to nRT. So we will have P dV plus V dP is equal to nR dt. So we have taken the differential of this equation of both sides, then P dV plus V dP is nR dt. We want P dV and it is P dV. So from 1 and 2 we get. So now from equation 1 and 2, let us eliminate N dt. So we have P dV plus V dP is equal to N dt. So we will use N dt R into N dt as minus P dV CV. So now let us bring P dV this side. We will have P dV here as 1 plus R by CV, and V dP I will bring this side minus V dP. So here again you see it is P dV coming into this CV plus R by CV is equal to minus V dP. Now we know that Cp minus Cv is equal to R implies Cp is equal to Cv plus R. This is from Mayer's formula. So I will write Cv plus R is equal to Cp and Cp plus Cv is equal to minus V dP. Now this ratio Cp by Cv is called gamma. We introduce gamma as Cp by Cv. That is called adiabatic ratio. So we have gamma P dV is equal to minus V dP. So now gamma dV by V is equal to minus dP by P. If I take integral of both sides, I will get gamma ln V is equal to minus ln P plus some constant, suppose I say plus log C, ln C as constant I have taken. So this is ln V to the power gamma plus ln P is equal to ln C, that is ln V PV to the power gamma is ln C. So thus from here you see what we got is PV to the power gamma is constant is equal to C, where C is the constant. So PV to the power gamma is equal to constant is the equation of state for an adiabatic process what we got. Thus, we see that the equation of state is PV to the power gamma as constant, where gamma is called Cp by Cv as adiabatic exponent. We call this Cp by Cv as adiabatic exponent gamma. Now, this is one relation between pressure and volume. If we use PV is equal to nRT and then P is equal to nRT by V, V to the power gamma is constant, implies T V to the power gamma minus 1 is constant. That means this is also constant. We can say it is in terms of PV, this is in terms of T and V. We can also get a relation in terms of temperature and pressure. So now you see here, for an adiabatic process, we can write the following relations. If this is constant, means P1 V1 to the power gamma, P1 V1 is equal to P2 V2 to the power gamma. And we can also write in terms of TV, T1 V1 to the power gamma minus 1 is T2 V2 to the power gamma minus 1. So, for an adiabatic process, pressure and volume, temperature and volume, and we can also calculate pressure and temperature relation will vary in this way. So, now let us see the expression of Cp and Cv in terms of gamma. So, Cp and Cv in terms of gamma. If I know gamma of a gas, how to express Cp and Cv with the help of Mayer's formula. So, you see here we have from Mayer's formula, Cp minus Cv is equal to R. So, let us divide both sides by Cv. So, Cp by Cv minus 1 is R by Cv. We call this as gamma. So, gamma minus 1 is equal to R by Cv, implies Cv is equal to R by gamma minus 1. So, if gamma for an ideal gas is given, that is Cp by Cv, then Cv becomes R by gamma minus 1. Generally, gamma is quoted given, so we write Cv as. Similarly, we can also calculate Cp. Again, we will use Cp minus Cv is equal to R. But this time I will divide by Cp. So, 1 minus Cv by Cp is equal to R by Cp. Now, this is again 1 minus gamma is Cp by Cv. So, 1 by gamma I will write. So, this becomes gamma minus 1 by gamma is equal to R by Cp. So, Cp is equal to gamma R by gamma minus 1. So, in terms of gamma, we have Cv is equal to R by gamma minus 1 and Cp is equal to gamma R by gamma minus 1.